Okay, so back to pH balance. I had left off with respiratory acidosis and alkalosis, and was going to move on to metabolic acidosis and alkalosis. If you remember, pH is measured from 0 to 14. It basically is measuring your hydrogen ions in the body. The respiratory alkalosis and acidosis is very similar to the symptoms in metabolic acidosis and alkalosis. So we'll look at that in a second. Metabolic acidosis is the accumulation of acid in the body. It is deficient in acid bicarb. So it's either the accumulation of acids or the being deficient, sorry, in acid bicarb. So if you remember back to our original topic of managing the pH through the buffer system, that acid bicarb is important because it's what is used to help take really strong acids and turn them into weaker acids, or it's a weak acid. The entire bicarb system neutralizes the hydrochloric acid, and that way lowers pH. So that's important. So basically, if we have a defect in that, you're going to have a higher acid. You're going to have acid buildup in the body, which of course will create acidosis. Part of this, and this goes back to the respiratory system working to stabilize pH. Part of this is just small respiratory. Basically, it's a pattern of breathing where your body's trying to blow off that CO2. Remember, I said low CO2 is low hydrogen. High CO2 is high hydrogen, and that's because your body takes the hydrogen and the CO2 metabolic waste product and turns it into free hydrogen, which is excreted in the lungs. So basically what your body's trying to do here is blow off CO2 to regulate that pH and get rid of the hydrogen, okay? Metabolic alkalosis, of course, is the opposite of acidosis. It's a loss of acid. So how do we have a loss of acid? Well, if you have nausea, vomiting, let's see, diuretic, excessive intakes of certain things, losses of strong acids or gains of bases. So if you decide you're going to eat, a carton of baking soda, then you are probably going to be alkalosis. So that's metabolic acidosis and alkalosis. So let's look at this one more time. The actual manifestations are, like I said, respiratory alkalosis and acidosis, and metabolic acidosis and alkalosis are pretty much the same thing. The only difference is how and what systems caused it. But again, the symptoms are the same thing. In either one, the CNS is depressed. So if you remember this drawing, I had drawn this for respiratory acidosis and alkalosis. In respiratory acidosis, you have somebody who might have alcohol poisoning, barbiturate overdose. I called it my college frat party. But basically, the respiration is low, which means they cannot blow off the CO2 and get rid of the hydrogen ions that it builds up in the body. The signs of this were drowsiness, confusion, headache, and coma. You have a low BP here. No significant GI issues, but you might have seizures. And then, of course, your respiration is hypoventilation or low ventilation. So that is respiratory acidosis. The metabolic acidosis, which again is very similar, is the same drowsiness, confusion, dizziness, headaches, and coma, low BP. You might have abnormal dysrhythmia, warm, flushed skin, nausea, vomiting, diarrhea. But the difference here is that the metabolic acidosis is created by a buildup of acid. It could be lactic acid. So, like, let's say you decide you're going to go do a megathon and you've been running for 100 miles. that is a buildup of acid in the body, or again, a deficiency of that bicarb. The metabolic acidosis, or as I was, the respiratory alkalosis. The way I explained this one was pretty much a student nursing final. So you're hyperventilating, you're anxious, you're blowing off tons of CO2, which creates a low um, hydrogen ion level in the body, and you can alkalosis. And symptoms of that were the same: dizziness, lightheaded, confusion, and headache. The only difference between respiratory alkalosis and acidosis is that this person is not drowsy, and this person is obviously extremely drowsy. With the metabolic alkalosis is a different process of having low acid in the body, but it's caused from nausea, vomiting, basically anything where the body has gotten rid of some of its acid. Excessive intakes of certain things, and again, if you decide to go eat a box of baking soda or something of that nature, or 20 bottles of Tums, anything that's going to lower your acid level in your body. So, the manifestation of metabolic alkalosis or dizziness, lightheadedness, confusion, headache. I should mention that the both respiratory and metabolic alkalosis have tachycardia. They may have dysrhythmia, nausea, vomiting, tremors, tingling, numbness, and muscular cramps. So the conditions are very similar. So that, in a nutshell, is in a nutshell of respiratory acidosis, alkalosis, and metabolic respiratory alkalosis. So how do I remember all this? That's the next problem. How do I apply this in a study? Well, that's where that Rome comes in, and of course I didn't get this on my own. This is something that has been passed around, I guess. But Rome basically means that we are going to look at our normal levels in our body, and we are going to compare them to figure out if a patient is alkalosis, acidosis, and what's the cause. Is it respiratory or is it metabolic? And we use this Rome acronym to help figure that out. So basically, let's start off by looking at our normal values. Again, pH 7.35 to 7.45. Think your body likes middle of the range. Middle of the range for your age is 35 to 45. We call that middle age. You have your O2, your CO2 is the same as your pH, and then you have your metabolic. So that's normally from 22 to 28. And the way I remember this is that your metabolism is pretty fast at 22 to 28 years of age, and then take that 3 and just turn it into an hourglass, and you'll find your hourglass figure. And a high metabolic rate from ages 22 to 28. Basically, that's the only one you got to remember, because out of your normal values, you look at this thing. Your O2 stat, it's important, but doesn't determine quite as much. It's 80 to 100. So you already know what CO2 is. If you look at that, you know your CO2. And you know your pH. The only thing left is metabolic. So that one has to be the metabolic. The only thing you have to really remember is this value right here, and this is the same value as that, so that's not too much. So metabolic is 22 to 28. When we take all of these factors, let's say we take a patient, and we compare all of these. So let's say our patient has a low pH, and then has a high CO2 and high metabolic. Well, respiratory opposite, metabolic equal. So that means that if I write these things down and I find that both of the values are either high or low for my respiratory and my metabolic, then it is your metabolic system. What determines whether it's alkalosis or acidosis is where you're at on this range. So if it's 7.2 and both of these are either high or low, I know that it's the metabolic system and that you're acidosis. All right. So respiratory is opposite, metabolic equal. So if my values are equal, both going in the same direction, up and up or down and down, then I know it's my metabolic. Respiratory is opposite. So if I look at this and let's say my pH is again 7.2, but I have a low CO2 or high and a high metabolic or vice versa, then I know it must be my respiratory system because respiratory is opposite. Um, I'm low, I'm 7.2, so I'm respiratory acidosis. All right, so hopefully that helps. I thought it was pretty nifty, and our instructor will explain that to us today. So that is how you're going to determine how if a patient is acidic, acidosis, or alkalosis, and from what system is coming from.